Are we live?
You're live.
We're live
Yeah,
on YouTube.
on the internets.
Uh, how are you?
I'm good. I'm out of beer.
God damn it.
I may have to get other things
I have some.
that are hidden in the house.
Oh.
Yeah, let's turn this up a little
All right. DARPA, Defense Agency Research Project Agency.
Oh, did you look at my tweet?
No, I just looked at what you DM'd.
Huh?
I just looked at what you DM'd me. Do you want to talk about space? Yes, I want to talk about space.
But how did you get DARPA out of it?
You said DARPA.
I didn't say DARPA. What are you talking about?
Just a while ago. You said
I
DARPA.
made a tweet.
I took notes.
Sony is DARPA. That's what that was. So, do you think space is a vacuum, or is it a area of which has negative influence of oxygen and H2O and things like that? Is it
I
a
think
vacuum like it
space-
sucks like a gay man, or is it a space which is negative and you would necessarily just... So how do you
I think
look at
there's
things?
preferential differences in space, within space.
Preferential differences within space? What does that mean?
No, not preferential. Differential pressure points in space. There's more gravity. It's not evenly spread. Like there's interesting peaks and valleys.
Peaks and valleys.
Space, yeah, space is big enough to accommodate a reasonable argument that we cannot be the only sentient species in the universe.
No, that's not what I'm saying. You're
just too big.
divulging. You're going past the argument. So let's say, for example, when you get past like the however amount of spheres the Earth has, and you get into open space, is it a vacuum, like, or is it a new? Is it a?
Yes,
Go ahead.
there is a vast amount. There's a big difference in pressure from the surface of the Earth to the stratosphere, where there is no atmospheric pressure pushing down. It's like when you dig up a sea creature that's used to living like in the Mariana Trench, and you bring him up to the surface of the ocean, he's going to explode because he's used to all that pressure pushing down.
Right.
So there's a pressure difference, and that they will explode. That yeah. Is it a vacuum? No, I don't think it's a complete vacuum. It can't be because there's too much stuff in the universe for it to be a vacuum. Is that what you're asking?
All right. So, looking at space as a... Now that I know that you understand that space is not a vacuum, how do you look at things that have so much mass to where when you take everything that they have and you put it into a small space, right? Because there's no vacuum. You're in emptiness. But when you get close to this object, let's just call it a black hole.
Singular.
It
All hell breaks
is
loose.
there
You get close
well,
to it.
is there singularity? One, but is there a vacuum in that relative region? Or is
It's not a vacuum.
okay, go ahead.
A singularity doesn't suck you in. It's not a vacuum. Oh, pressure differences. That's what a vacuum does. It
Right.
just sucks out all the pressure. But a black hole is not. It's it's not in a vacuum, but is not a vacuum.
Right.
It's just distortion in space and time.
Right. So
Elements that light can't
right,
escape.
right, right. So have you heard of the vacuum manifolds? Or have you been getting links on YouTube about like certain female scientists that uh is doing research or has been doing research on these like vacuum manifolds and
What is it?
so say for example, this is why I personally, to be honest, I DM'd Anthony first and he never replied to me, and then I
Wow,
DM'd you second.
what a stuck up motherfucker.
Yeah, apologies.
Vacuum man.
So but like in the vacuum manifold, if you were to look at it, because you're a gay guy who knows mechanics, if you were to look at it from a intake sucking in air from a cold air
Mm-hmm.
intake and the
Right.
volume that's inside of that manifold that has two runners,
I get that.
or
Yep.
excuse me, that has four runners or eight
Mm-hmm.
runners or 10 runners inside of that um, manifold, which is what it is. There are variable equations that you can
Inject it into the combustion.
yeah, well, no,
All
don't
that.
look at it
Yeah.
like that. Don't look at it like that. So this is what's been this is a very interesting thing, and I'm curious if other YouTubers, or not YouTubers, but people who have YouTube, have been getting these type of suggestions who have interest in space. Um, so in that manifold, there are math equations through trigonometry and just basic
That
math,
do what?
algebra, and all that, where you can get
What do they end
a
up doing?
three-dimensional relevance to that vacuum manifold, but you can also transverse the outer region of that manifold. And what's been very interesting here recently, because you remember one of the biggest, you know, space. What's the word, like space? Uh, space travel thing. I don't know, like where you take a sheet of
Uh,
paper and you fold it over and you stab a pencil through it, and you're able to
yeah.
travel.
Fold,
Yeah,
folding
folding
space.
space. Yeah,
Like I want to go from here to here. It's going to take me a long time. So why just I fold it?
yeah. So
Like
so what I gather has been going on is that's no longer a thing. And
it's
what they are trying to do now in science is figure out this manifold math that somehow correlates to black holes and how quantum mechanics, or whatever you want to call it, is able to exist at the same time, but also negatively and positively exist in the same area at the same time.
right. Like how do we know that this is not all bullshit?
Well,
Uh,
hold on.
I listen
This is
to people like Brian Cox, and I used to listen to Neil deGrasse Tyson when he was,
well. I'm
and
going to bring him up tonight. I'm actually going to bring him up tonight.
astrophysicists that and Copernicus and all them who have described for me, have laid it out and explained how the universe works. Why should why shouldn't I believe them? Why?
Yeah, yeah, but we're not having that argument. That's not an argument I'm having. What I'm saying is, it seems like in the recent studies, they have put away the folding of the sheet of paper and stabbing a pencil through it,
Mhm.
and they're now trying to look, and they're now looking at these vacuum manifolds.
What does that mean?
Well, they are able to. So
Vacuum
so
manifolds.
when you this is so my biggest argument in these things like teleportation and things like that is you can't transfer the consciousness. So like if you teleported from here to Alpha Centauri, like there's a
Right.
machine that teleports you, there's
And
no way to take your conscience with you.
let's say theoretically, they it was able to rearrange every single atom in every single position that it was when you entered the transport. Would not the consciousness be preserved? Isn't that what the consciousness is? It's just a
Well,
series
if
of
you were to if you were
chemical
to
and electrical impulses that happen in the brain.
I it doesn't it seem it seems like that's maybe something that they're trying to figure out in some vague way
Hmm.
with
Hmm.
this this vacuumless manifold sucking in behavior, right? Because essentially what they've established is that um there is essentially no big bang, and that the weight of the matter in the regions of space at any particular time
Hmm.
throughout astronomical history, there's always a quote unquote explosion happening. And it's really interesting is because in the um what is it, like the Jeb, I don't know, that little triangle telescope, they're actually finding what they would quantify or what they would justify, however you want to verbalize it, is they are looking so far back into the past that what they are seeing is the creation of other universes.
Yeah, 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 yeah. That
And
blows my mind, bro.
because
Staggering.
yeah, yeah, and the distance in between is so vast
Vast.
that there's nothing in between it, not even
It's
quote unquote
vacuum,
dark matter,
but it's still not a vacuum, even though there's
and there's
vast
no vacuum.
one little particle.
Yeah, there's no matter, there's no light, there's no little bitty bits of particles. It's very interesting because it almost seems like there's a war going on with how to redo these books in schools, and
Yeah.
it seems like to me, because what YouTube keeps giving me, and maybe I'm feeding into it, but like these whole vacuum manifolds are like the new argument in folding space. And it's very interesting. And I'm going to actually show a video that I was just
Yeah.
watching. I was going to go to sleep. I ran out of beer, but I decided not to because I was like, I'm like, even Neil deGrasse Tyson, who's
Yeah.
political at this point, isn't being political. So it's quite interesting.
Okay. I'll
Um,
send his pros.
so we can do So I thought this was interesting because they don't bring up the whole vacuum manifold scenario in their arguments, but their argument is talking about this three-dimensional system that has like there's literally like a wall so it's like a giant sponge, and not every arm of the sponge is perfect, and there's like these boundaries that they're trying to figure out how to travel or get signals through. I imagine it would be signals.
Yeah.
Because once you get out out of like these certain realms of space, like it's
start with the solar system. That's not very big, but
yeah, like the time of distance that you're able to get the signal is increased by X amount of time that you're away, of course. But at the same time, space is expanding in every direction at every point of time.
Theoretically,
Yeah,
faster than the speed of light.
Yeah. So I assume everybody knows that.
Yeah, that's a pretty safe assumption that everybody knows that space is expanding faster than the speed of light.
No, that's not. Well, some portions are expanding at the speed of light, and some portions of space are expanding at double the speed of light.
Oh, and some are not so.
And what's interesting is those universes or solar systems that are expanding at double the speed of light. With our technology, we can never take a picture of them or the light.
Can't do anything. We're just left to speculate. We can't ride that wave. That sounds like a big.
So isn't that odd? Isn't that odd? That's a very perplexing. Like if you actually have interest in space and all that stuff. And Courtney, you're not banned here.
It's the guy on the beach that's strapping together some logs, and people come up to him and say, "What the hell are you doing?" It's gonna ride these logs over that horizon where the ocean is going all wobbly. The first person that wanted to step out of the cave. It's all exploratory. It's all sort of wonderful and nice, I guess.
Can I share? I hope I can share this.
Why else would it exist? That's the thinking that we've had.
Wait, just let me back up for a minute.
Yeah.
So as I was learning particle physics, I was intrigued to recognize that you have your electron, you have your photon, you have your neutrino, and these other sort of basic particles. And they exist in our world that we experience. Okay. If you up the energy knob, other particles manifest. There's a version of the electron that manifests only in these higher energy levels, and it's called a muon.
Right.
Okay? And so there's a whole layer of particles sitting above the ones that are in our world.
Right.
So there's 3 of these layers. And tell me the 3 electrons.
You get the electron, the muon, and the tau.
The tau.
Yeah.
Okay. And there's an electron neutrino, there's a muon neutrino, and there's a tau neutrino.
Yeah.
Right.
So now I have 3 layers here, and you have access to them in your particle accelerators because it takes a lot of energy, and you can get there.
Yeah.
Okay. Right. Now, what does supersymmetry do with this package?
Supersymmetry says
this package is
beautiful and confirmed.
And tell me the 3.
Do what?
Sorry. I was yelling at Neil deGrasse Tyson for not letting the white guy.
Oh, he interrupts horribly during this. It's hard to watch, like the Jew guys, like, oh my God, dude, like, can I answer a question? So, but he does good. I mean, for what you can.
The 3 force carriers, we have a photon.
You got the photon, then you got the gluons, and you have W and Z bosons, or the weak nuclear force.
Okay.
And those are the 3
discovered by
forces.
Bozo.
Yeah.
Right.
Bozo.
Yeah.
All right. So what's interesting? So this is kind of interesting. What's been going on recently? I don't want to say rumor mill, because like I read I'm a fucking autistic nerd, right? So what they're
the thing that gives
so
mass?
hold on. Don't even pay attention to that. What one of the arguments that is going on now with like black holes, it's not so much the amount of matter that's crushing into a heavily weighted zone. Like there's so much weight, just everything is being sucked into it because of there's so much weight in this tiny, tiny, tiny amounts of space. Like if I was to hold a black hole in my hand, it would rip through my hand and rip through the earth and rip through the sun. Like that's how heavy it would be.
Yeah.
Right? What they're saying is that these boson materials, that every time you quote unquote weight them together and at the same time pull them apart, and every time they rip apart, they're making like double and double and double the amount of material. But that material that's being made is being made out of the wavelengths, the aura, like the invisible bubble that's around them. And when that invisible bubble gets shredded, that is what adds mass. And it's not necessary. Bro, it's very
Does it matter how we get mass times the speed of light squared? All I know is I have this wireless mouse that I can click around.
So think about what I just said, right? So think about what I just said. It's not the mass that's quote unquote being pulled into this black hole. It is the energy and the aura around the mass,
the Hawkins
that is being sucked into it. Right. That when it's being shredded and disintegrated,
a black hole.
Say it again.
Nothing can escape a black hole, but Stephen Hawking said that there's Hawking radiation coming off a black hole.
Isn't that? It's not radiation though.
But so gravity is the weakest of the forces. What is it? Gravity, the strong nuclear force, the weak nuclear force, and the electromagnetic force. Right? That's 4 forces. Gravity is the weakest, but if you concentrated it enough into a black hole, then galaxies can form around it, and then you have us.
It's interesting. It's interesting.
We're talking to each other because there's a black hole at the center of our galaxy.
Yes, absolutely. And what's falling into it is everything, but at the same time, it's nothing. And everything and nothing that falls into it, when it shreds into oblivion, that is where the energy comes from that gets sucked into the black hole. And
is there any information that is not destroyed as it falls into a black hole? Because I don't think it's getting sucked into a black hole like a vacuum cleaner suggests. I think you're just falling into it.
I'm curious. I'm curious about all that. There's a book. I want to talk about it. And go ahead. What'd you say?
Let's build a rocket ship and go find out. Let's travel up there.
Yeah, they're in the book, The 3-Body Problem, which I actually want to kind of go over that clip later on this, which is a book by Lu Zhaojun, and it's called The 3-Body Problem. Where that also puts into perspective a little bit of uh, some of the arguments that they would give for this.
What describe the three body problem? What is it? That three bodies can't orbit each other or something? What is
Well, so we're a two-body system where we live, Earth, Moon.
in the sun, in the moon?
But also so that's a micro perspective. When you break it down into a macro perspective, it's Earth, Sun, right?
Sun, solar system.
In the Liu Xiaojun book,
Galaxy.
yeah, the Liu Xiaojun book, that book is about a species, an alien species, who decimates the human species. But
Motherfuckers.
yeah, they're assholes. But the underlying basis of their story is they come from a solar system where there's 3 suns. And two of those suns, while they may be in unison from a solar system perspective, there's a third sun that comes in and just fucks shit up.
Oh,
And in that solar system,
a binary system.
And it's just every once in a while it'll just
and
it'll just
right.
And in that solar system,
That's cool.
there is an alien species who cannot figure out the 3-body system. They cannot figure out the math to survive this. And so they find out in China, they find out in China during the 50s when the Mao shenanigans were going on. A Chinese scientist makes contact with an alien from the 3-body system, and that's how the alien. Bro, it's so deep. Is this
the one where they're all standing on a field and they're holding up ones and zeros?
No, not at all. It's not at all like that. It's not at all like that.
Okay.
So anyway.
Actually, Bose. Yeah. Bose is an Indian physicist.
Yes, absolutely. Yes. And then for the quarks, you got the up and the down that we spoke about. You got the charm, the strange. You got the top and the bottom.
Right.
So again, they come in 3 pairs of 2.
Yeah. Okay.
Yeah. Supersymmetry says take all of those particles and double them. Another shadow version of all of those particles.
It's a shadow government.
For the electron.
We are the puppets.
What's up?
Look at Neil. Who is that comedian in the middle? So there's a Jew guy on the right. There's the comedian in the middle, and then there's Neil deGrasse.
And they've been together for
right. Decades. Star Talk. Yeah, they've been doing it for a long time.
Yeah, this black dude's name? No clue. Black sidekick.
He's a comedian. He was a comedian.
Shut up. Just listen.
The deep state.
This is the deep state. They are the puppet masters. The quantum deep state. Wait. So I didn't know this. The entire set of particles would have a counterpart in this supersymmetric place.
So for the electron, you have the supersymmetric electron. For the quarks, you have squarks. For neutrinos, you have neutrinos.
People just making shit up.
You do run out of names after a while.
Latest cartoon.
But here's the thing. This is all mathematically motivated by a completely compelling rationale. So this is not pulled out of, thin air.
We have our universe 3 ways, a 3-layer cake. And there's a whole other cake. Where does that live?
So it's awesome. And let me just bring up the 3-body problem. In the 3-body problem, there's also another race of aliens, and their body, their human like how they exist, their body looks like a nebula.
Okay.
And they're so ancient and old, and they have a weapon that they use, which is like a note card, which is a lot of Liu Xiaojun.
They have a note card as a weapon.
Yeah, and it's a lot of his underlying story goes into science, but is also the oppression of the Chinese people. And this note card this weapon that these ancient nebula poets put onto the universe. Anytime they are found in existence or they find another intelligent life form, they immediately murder them and obliterate them.
Those bastards.
Yeah, and this note card, this thing that they use in their ancient wisdom, turns their 3D universe into a 2D universe. So it flattens out all existence into a 2D uniform plane where, because of space and vacuums, they are wiped out of existence. Like that's this nebula weapon that has a conscience. They turn all existence into a flat plane of existence.
Do you think it's possible that the universe is conscious?
That's like a really deep message.
I think it's possible. I'm not going to rule it out with my limited knowledge, but I'm not going to worship it either with my limited.
But let's listen to a little bit more of this, and then let's. All right.
Us, but we believe they're more massive, which is why we wanted to build the superconducting super collider to try to find them. Now we've looked for these at the Large Hadron.
If they're more massive, why aren't they right here in front of our faces?
They typically have short lifetimes, so they'll decay into lighter particles. But the lightest of the supersymmetric particles would not decay, and therefore it should be all around us.
Tell them why the lightest one would not decay.
If it's the lightest one, when it decays, the decay products have to be lighter than it.
Okay.
And so if it's the lightest one, subject to a certain
it's no place for it to go.
law.
No place for it to go.
There's no place for it to go.
In essence, yes.
Exactly.
It's the same reason why you can have an energy field of any kind, and
for it to go.
You will not make particles out of that.
Right.
Unless the energy available is higher than the E equals mc squared of 2 electrons.
Right.
Because it has to make them in pairs.
Okay.
To keep the charge conserved.
Because it's plus and a minus.
Right.
And so an electron is the lightest physical particle. Is right.
Do what?
That sounded like it made sense. Like,
well, because it did make sense.
MC squared times 2 particles.
Well, the energy, which is equal to mass
times the speed
squared.
Squared.
You can that from that existence, when it's decayed or destroyed, it releases energy.
It can't be destroyed. Isn't that a like a theorem that energy and mass cannot be created or destroyed?
Yeah. And so, and then from that destruction,
energy equals mass. That's a E equals mc squared. Energy equals mass.
Well, what they're saying too is, remember I was talking about that tear and fabric of quantum energy, that field, that aura. When mass is destroyed, there's a function that in that destruction, from that decay, from that breaking of that aura, that orb is where the mass comes from. So it's kind of like a gamma ray.
Higgs boson.
You know what I'm saying?
Yeah, I know.
You're retarded.
I know, and drunk. It reminds me of the Higgs boson particle, which gives other particles mass. I don't understand how that works.
Mass isn't actually destroyed. It's the aura around mass.
The energy
that can be torn in a quantum level. And when that tearing happens in that quantum level, that is what expends energy. So it's like, it's not really the mass, so to speak, that expends energy. It's the energy around the energy that expends the energy. It's really dumb.
I guess.
But it makes sense, right?
No, but I like the way you say it.
Just like when you slam photons together,
Mhm.
That energy exists no matter what.
They found the Higgs boson part here.
But when you slam them together, they make a new energy. But when you slam them together, there's an orb around them that exists. And that is what actually does the things,
Okay.
not the energy itself.
Um,
That's how deep they're getting into the physics of it.
right. The bit that I don't.
Yeah.
Yeah.
So nothing's happening.
Lightest
That's
charge
why it's
particle.
not happening around us right now.
Yeah, it's the lightest
Right.
charge
It's charge
particle.
particle.
So
Right.
it has to talk the electromagnetic field. For
There it is.
instance.
That's why light coming from lights is not just making particles. It doesn't have enough energy.
Yeah.
Right.
But if
it did?
if X-rays started coming out of there, X-rays, high energy X-rays, you can pop electrons into existence.
Yeah.
Because they're stepping down, so they leave something.
The energy of the field is big enough to create the electron and anti-electron, and so it will pair produce them.
In fact,
That's so wild.
electron microscopes are enabled by X-rays, creating them, and the wavelength of X-rays is so tiny that you can see tiny detail. It's tinier than the detail. You can't have resolution higher than the wavelength of light that you're using
you
to
can
see
use
it.
to see it.
Right.
Right.
Now, back to dark matter, just to finish
Right there.
this point.
So this is a whole massive other layer cake.
Yeah.
And you're telling me that is the mass of the dark matter.
Well, the lightest supersymmetric particle would be stable, should be around us.
That's what
so
everybody's
maybe
looking
it's
for?
filling space.
Right.
And here's the beautiful thing. This will
So
blow
this
your mind. This will
actually
blow your
makes
mind.
sense.
This
Our
will
mind's
blow your
already
mind.
blown.
When you do the calculation of how much of this lightest supersymmetric particle should be left over since the Big Bang, it exactly matches what you need to be the dark matter. It comes in the right abundance.
Dang.
And yet we've not found it.
You
And it
haven't
may
found
be
it.
the wrong answer. So sometimes things that just seem so deeply compelling are wrong, but we don't know yet.
Wow.
So do you know?
So dark matter is matter that we can't detect that is going to produce a gravitational effect that is going to pull the universe back in.
Our math is
And
not
there's
good
also
enough.
Dark energy, which is expanding the universe.
Well, energy and matter are different things. In
No,
these,
they're the
in
same.
these arguments.
E equals mc squared. They're the same. Energy equals
Well,
mass. They're the same. Energy and mass are the same. It
On
says
a-
so in the equation.
But on a quantum level, that's not real because, as I was explaining, it's the aura, it's the bubble that when the bubble bursts, that's what gives energy. It's not the stuff that's inside of it. And so there's a hidden math equation that we don't know yet that can give information as to why there's so many dark regions in space. And we don't have a clue that math yet.
How do you know it's not all okay? Have you done the math? I haven't. I'm not gonna.
No one can.
Some people can. I think there's very few people who can. And then there's more people who can understand it once they read it and say, like, oh, okay, that makes sense. But even those people are sort of rare. I can't do it. So I have to rely on the likes of Carl Sagan when he did his Cosmos series on PBS. Back in, when was that? The 80s, early 80s, late 70s or something? Which was brilliant. So who do I depend on?
Well, all that stuff is ancient history now.
It's not ancient.
Yeah, it is.
You're saying ancient history when you're talking about a universe that is at least 4 billion years old. At least.
Well, what
if
I'll get into that in a minute. Well, more than a minute, but I'll get into that. But at every giving moment, there are new coalescing, ethereal, eternal explosions of multiple universes happening at one time, everywhere, always. And they're trying.
We don't live in any of them.
Well, we live in the one that we live in.
We live in this.
And then so it's like so.
Communicate with them.
And so what they're finding in the James Webb telescopes is they're finding mass that is younger than what we would calculate as the expansion of our universe.
So they're finding mass younger than the universe.
And in that mass, they already have formed galaxies.
So what is the universe going to do?
And
expanding until every subatomic particle drifts apart, and then there's nothingness, or is it contract in on itself at such a velocity that it's then going to explode?
And it's happening everywhere all the time, essentially.
And spawning new universes and
everywhere all the time.
Hmm.
And I'll show the video here a little bit after this one.
Enough in the theory of these particles to predict how you should detect it?
Yes. Now they can vary which is the lightest supersymmetric particle on the flavor of the supersymmetric theory you're looking at. But in any given version, yes, you know exactly how the particle interacts.
Okay, so now you have everybody's favorite flavor, the theorists, come out with their competing models, but still they got to have one of these particles. Okay,
yes.
So now I'm a experimentalist, and it's let me test for this one. I don't find it. Let me test for that one. I don't find it. So it's not looking good.
Yeah, I agree.
Okay,
I agree.
Okay, Apple Podcast and most
is not
all that is cosmic months ago, and you explained to me, and I've said it here, that there are ideas percolating that the fabric of space-time might be woven by wormholes that connect the virtual particle pairs that come in and out of existence. And that if they're connected by wormholes, rather than just some field, then the wormhole is an actual structural texture.
You hear what he's saying? These manifold.
I think so.
These manifold ideas.
Right. That instead of folding the paper in half and then shoving a pencil through it, there's new ways of thinking about the fabric of space-time.
Yeah, and in that manifold, there's a suction which brings them, and I think they give it a Hawaiian name. And in that coalescence of all of the matter that's coming into here, when it's expelled, it is expelled at a different portion of the universe that's still a part of that manifold.
I don't understand what a manifold is.
So it's a three-dimensional object, just like the air intake manifold on a car. So there's an intake and there's the aluminum plenum.
Mm-hmm.
In that plenum, the air that's inside, the mass that's inside of that plenum, the air intake, has a volume metric. Like you can do the math, and you can, so say for example, if the fourth runner on your
so you can build it around.
Hold on. So the fourth runner on your inline 4 motor is getting less air. You're able to adjust through your 3-bar map sensor how much air comes in.
Fuel mixture.
Right. So that's a manifold, right? And so if you can picture that in a 3D perspective, so that's what he's saying. So we'll go back just a little bit.
Explain to me, and I've said it here, that there are ideas percolating that the fabric of space-time might be woven by wormholes that connect the virtual particle pairs that come in and out of existence. And that if they're connected by wormholes, rather than just some field, then the wormhole is an actual structural texture of the universe.
Yeah. In fact, the other
All right,
way.
now I'm sorry.
What?
First of all, I need some weed.
Yeah.
But do you see what he's saying?
Big ideas.
To even
Texture
Kinda.
of
That
the universe.
Yeah. In fact, the other
All
way.
right, now I'm sorry.
theoretically,
What?
black
First of all,
holes could be used.
I
to
need some weed to even deal with.
theoretically, black holes could be used to stitch the fabric of space-time in any fashion that you wish,
Theoretically.
as
And
long
I
as
don't
you have
think
the
in any
enough
fashion would be
energy to do it.
No, so what I think, that's not at all how I picture that. They are trying to figure out how, say for example, if you're in a giant sponge, which is
Right.
the cosmological background of space.
And the universe does look like that
Yeah, and it's a giant sponge.
like super clumps, and it's all
Yeah, instead of trying to fold over a sheet of paper and stab a thing through it and find out the two coordinates,
I see.
they're saying in that vacuum manifold, in this existence of this 3D object that we live in through trigonometry and all that,
Yep.
you should be able to calculate,
I see.
possibly if you have the propulsion technology,
Shortest route.
how to get within that 3D manifold, how to get within that quote unquote vacuum that's not a vacuum, but the manifold, the thing that is inside of an object, which is the material that is inside of space, outside of dark space, which is empty and has no volume. They're trying to figure out how to navigate to get from that bottom, go around the manifold of the equation and get to the top without necessarily going from point A to point B, but using space time. Because remember, there are objects in space that go twice the speed of light. They're trying to figure out an equation to get them there before A and B, but using a 3D model. So it's a very...
So what does that mean to getting people on Mars? Is it important, do you think, K-Dollar, for humans to have babies on Mars?
I don't think it has anything to do with that, but
I know, but is that a good idea for humanity to have babies on Mars? Raise generations of humans on Mars?
Yes, it is required of the human species to be on as many planets as possible.
For the sun.
Shut up.
With this. Because if I'm trying to figure out what you just said here, because it's so freaking, I mean, it really is just crazy.
Wait, let's back up. The vacuum of space is not a vacuum.
Right.
Because quantum physics requires what?
There's all sorts of uncertainty, and that uncertainty means that there's fluctuations, and therefore there are particle-antiparticle pairs, there's energy fluctuations, there's field fluctuations.
Right.
It's a roiling mess out there in empty space.
And so there's no nothing.
Yeah.
There is no such thing as nothing.
That violates uncertainty if it was truly nothing.
Right. If there was truly nothing, we couldn't have uncertainty.
Yeah.
So the uncertainty is, gives us the fact that we do have virtual particles.
Yes.
We know that they pop in and out of existence. Well, what you're trying to tell me?
I think it's not that we know they're there. No one denies it because it's completely consistent.
Well, I'd say the Casimir force, where you actually put two metal plates in otherwise empty space, they should simply sit there. They're drawn together, and our best explanation is it's the virtual pairs of particles. It's the fluctuating film.
I didn't. I feel like I have fallen into a Star Trek nightmare.
So you take two exactly parallel plates.
Okay,
and evacuate what's in between
them. That makes sense.
The best vacuum you can muster. Then you slowly move them together.
Right.
There is a point within which a whole other force kicks in.
That's right. And it's not the gravitational force.
It's not
the
electromagnetic.
electromagnetic force. Rather, it's a force that comes from the Casimir field, which is basically...
That got a Nobel Prize, the Casimir?
Well, 1948 is when it was discovered.
Okay.
It got one in my book.
But it should have.
You just gave it one.
I just gave it one.
Yeah, it definitely deserved one.
That's
But
insane.
it's an imbalance between the fluctuations of uncertainty within the plates and the fluctuations of uncertainty outside the plates.
Oh.
And it's that imbalance.
Creates a force and puts them together.
Yeah.
Okay. Okay. So that's how we get the particles in the vacuum of space. Okay. So now,
Unbelievable.
what
which is in a vacuum.
compels you to say wormhole rather than just a field?
Well, because it really comes from the idea of quantum entanglement. What we find is that entanglement, which normally we think of as particle pairs, but now we're finding that the vacuum of space may be stitched together by the threads of quantum entanglement itself.
Like each other.
So
That's
deep
crazy.
down within the substrate
Neil
of reality, it may...
and a Jewish guy like each other.
What?
Do you think that this Jewish guy and Neil deGrasse Tyson like each other? I've seen this guy before.
It's a possibility.
They like each other.
It's like in New York where they play chess in Central.
Okay, yeah, that makes sense. Okay.
Same thing. Yeah. But you're not listening to what he's saying.
I'm trying to. Okay, Don.
Entanglement, which normally we
particle
think of
pairs
as
are entangled.
particle pairs, but now we're finding that the vacuum of space may be stitched together by the threads of quantum entanglement itself. So,
like, have you heard the quantum mechanic computers that have been going around
I think so.
on the internet? Like Microsoft built
What's
Willow and these other things, and they're solving math equations, so very basic but quite complicated math equations, and they're structurally absent of vibrations, because soon as vibrations interact with their ones and zeros, so to speak, they break in the structure. Because, like, say for example, it exists, and then as soon as you look at it,
Right.
it breaks. Right?
right.
They're able to catch the
That freaks me out, bro.
they're able to catch the material that breaks from that quantum level and put it in a nanotube, and that's what they're able to send back ones and twos, ones and zeros, A's and B's.
It's clever.
Yeah, they can act, but that's in the quantum computers that they're doing now. But they're so rudimentary.
So it's
It's
not
like-
ones and zeros. There's four, like DNA. There's
Well, they can stack on top of each other, and you can actually catch the quants, or whatever you want to call them, in their. You can catch them when they're decaying and
right.
put them in a tube somehow. That's fucking insane. And then from that information, you're able to give it a little bit of zap, like in a computer chip or like an Intel chip, and they're able to respond off of the signals giving to them from like a positive. So there's a tube and there's a signal. There's a piece of copper here and a piece of copper here, and they send a signal, and depends on how it relates in that tube when the signal shuts down is how you get your ones and zeros and all that. And from that, you're able to take rudimentary steps from a old school IBM computer that you play Pong on, and you're able to.
I remember that.
You're able to level up to where you get like. Yeah, so so that's what quantum computers are. The material that they catch in the nanotubes supposedly is solving the equation in a quantitative state on the other side, wherever it is in the universe.
I don't know what any of that means.
So even though
But it
you
sounds-
send the signal inside of that tiny tube, by the time that signal registers on whatever side of the board you want, the 1 or the 0, because remember, we're making it rudimentary here. On that side of the 1 or 0, by the time it reaches either side of that tube, that material that is in that tube is on the other side of another side of the universe, and that's where that signal comes from. And it's not really in the tube, but it's in the tube. And that's how you get your answer. Isn't that interesting?
I guess kind of like that cat with the universe on her collar.
Which is funny, in the 3-body problem in the Liu Xiaojun book, all the scientists are killing themselves, and one of the main story protagonists in that story is working on nanotubes. And it is so
nanotubes made out of carbon.
Well, I don't think they really get it. So in the American version of the nanotubes they make,
are nanotubes made out of carbon in the here?
I think they're made out of silica and other materials. There's variations of nanotubes, but they're tubes that are nanoscale that have a hollow area inside of them. And inside of the 3-body problem, the American version, the scientists that were working with the aliens from the universe that had the 3 suns, they actually, after the scientists, because there's a countdown in their vision, it's because they're working on science.
That's a hard deadline.
Yeah, so every scientist that's working on physics, the aliens from the 3-body system that has 3 suns, they have a countdown on their face, and they're just driving them insane, and they all end up committing suicide.
Oh.
One of them who's working on the nanotechnology, the nanotubes, in the American version, they actually create this giant Jurassic Park thing where it's 2 giant pillars, and in between them are the nanotubes. So as this ship is going across, and it has these crazy scientists that are talking to these aliens, it slices everyone to pieces. Because the nanotube technology is so sharp, it'll cut a cruise liner like ham, like a Sunday ham, and it murders all these children.
Sell it on QVC.
Yeah, it murders all the children. It murders all the crazy scientists. It murders everyone on this ship. Fascinating story.
It's on Netflix.
Yeah, the American version of the 3-body problem. Yeah.
So deep down within the substrate of reality, it may all be stitched together by quantum entanglement. And then other work shows us that quantum entanglement connecting two particles is just like a wormhole, going from one to the other.
Because what happens in one happens to the other instantly.
Yes.
And that means they're touching each other in that instant.
Connected in some weird way. And
what they're kind of saying is that once these quantum entanglements meet such a mass demand outside of what you would qualify as a black hole, that these quantum entanglements, these because every time you destroy something, when it splits, it becomes 2. And then when the weight of the system that is physics, every time the weight increases, those 2 quarks or whatever split, and they become 2 more. So then you have 8, and then 16, and then 32, and then it just quantifies, and it just puts so much weight in this area, and that information inside of those quote unquote black holes is also similar. It's within physics reason, but not proven through math, that the information inside of our black hole, which makes our universe, there's also the exact same information in this little fuzzy hole that they call it, that is being repeated. And in that quantum state.
That was one of the questions I think that Stephen Hawking was asking: is information lost when it falls into a black hole? I think he said no, that information does indeed escape from a black hole in the form of Hawking radiation.
Yeah. Yeah. And once the quote unquote black hole or quark mass reaches a certain weight and certain size, it starts blasting out gamma rays from the north and south pole, because it's taken in so much information, and it's doubled it and doubled it and doubled it and doubled it for eons. And then as that doubling of that quantitative energy or whatever swells so much so, it can start to bring in mass around it.
Yeah.
And that's what you could identify as what would become like a new universe once it has recycled and the quantitative mass has increased so much so, however, whatever goddamn number, quintillion.
Light can't escape.
Yeah.
But
and then but that's happening everywhere all the fucking time.
Yeah.
All the time. On both sides of that quantitative mass that we can catch in a goddamn tube.
Energy equals mass times the speed of light squared.
Isn't that crazy? It's pretty crazy.
It's nuts,
like,
bro.
I can picture it in my head.
Yeah.
Entanglement is one language, but we believe wormholes may be the general relativistic version of that quantum language.
So it's like a little quantum net holding the whole universe together.
Exactly right. Because we find mathematically, if we cut the threads of quantum entanglement, which we can do mathematically, space falls apart. It discretizes into little tiny pieces, and it just disappears.
Okay, Dollar. What is quantum entanglement? Is that like two particles could be on opposite sides of the galaxy, or maybe even the universe, but if it's spinning right and the other one is too, and then it's instantaneously, if it starts spinning left, the other one does too, through vast distances of space and time. Is that what quantum entanglement is?
Is it spinning? I don't know.
It's something. They're behaving some way, but behave in the same way at the exact same time.
But they're not, because there's no time.
It's in the other one.
Yeah. So it's like literally taking. So we can guarantee that there's galaxies traveling through space at the speed of light.
Ours is.
We can guarantee through math and some of the satellite imagery and everything that's coming out that there are actually galaxies that travel twice the speed of light. So if you were to continue to square that up, there is enough information that can be here and there at the same time through these certain regions of space. It's not everywhere. That doesn't happen everywhere. Yeah, this thing. And I think it's really fascinating, because when they talk about it in the videos I watch and everything, you can actually kind of start to grasp what their argument is, like visually. but how do you, even though we can catch the break of the quant in a tube and observe its back and forth signals in a visual capacity, so to speak, the material before it, when you observe it, it decays and dies.
Yeah,
So
like things behave differently if you're
so it's like
not paying attention to them, and then once you pay attention to
gone.
them, they behave.
It's
differently.
gone. So I
Yeah.
think that's a
Well, it's not gone. They just behave.
that's a
differently.
math
They
equation.
do something else. It's like it's either particles or waves.
Yeah.
Like if you don't look at it, it's particles. If you do look at it, it's waves.
Yeah. And that in a extremely difficult math equation with crazy weight, crazy material, it can be because this shit is so vast. There is no such thing as time, because where you are relativistically speaking in any different area, depending on the gravity around it specifically, that can distort the relevance of space-time completely. But if you move a couple light years to the right and you're no longer around that gravitational pull, the weight
Just a couple
is completely different.
light years to the
Light will, so it's like, oh my god, it's just so like some of the things that they're explaining, I'm like, I don't know if I'm super autistic here, but like,
So the further out we look, the further back in time we're seeing. And Brian Cox said that we can see the beginning of the Big Bang by looking outwards.
but technically
weird.
we can't. We can only see the radio background of the explosion. So the ancient prehistoric shifts in space-time, we can measure that
to the Planck second.
Well, what's cool is they're going to have, because you remember we got those lasers that are like a giant L. They're creating a new one, which instead of making this giant L, they're going to point it up straight into space, and they're going to have a satellite, and they're going to shoot the laser from the base command to that satellite, and they'll be able to catch gravitational waves from that satellite instead of it being like, it being the Scissor Sisters, like 60 kilometers or whatever, it's the ground to that space satellite. And you'll be able to catch that cosmological radioactive background in a much larger distance away, because it's always rippling. It's, even though that rock is come and gone, that ripple is still rippling.
Bro, this sounds like a hippie song.
Yeah. I mean, it's fascinating shit.
Yeah. It's the dawning of the age of Aquarius.
No, Chuck, I need you to the end of this. Chuck,
Dude,
don't leave
crazy.
me. Don't leave me,
Oh
Chuck.
my god. Oh my god. Dude, that's insane.
Now, look, it's mathematical, but it comes out of our cutting edge ideas. It all makes sense.
It just makes
He's
sense.
saying he's not pulling it out of his ass.
Right.
Okay. He's saying the math gave it to him.
Works.
And he started out saying my boy loves the math. So now, last thing.
Yeah.
Boy loves
Explain
math.
why
boy
you need more than 4 dimensions for your string theory universe.
Well, it's a very concrete explanation. When we look at the equations of string theory, there's a consistency equation where something must equal 0 or the math doesn't work. That something is a product of two things. One term is really complicated. It's never 0. The other term is the number of dimensions minus 10. The only way to get it to be equal to 0 is for D to be equal to 10. That's it. I am not joking. This is where the constraint of extra dimensions comes from in string theory.
The math is forcing our hands.
Forces your hand. And then you say, well, let me take this math series. And one thing you could say is, well, if it's
algebraic formula.
What?
Can you write what that Jewish guy just said in an algebraic formula?
You Google it. I'm not Googling it.
I can't either. Or you're right. Go ahead.
not D equals 4, 3 space and 1 time, throw the theory away. Others of us will say, hey, let's consider the possibility.
Don't sell the universe short.
Yeah, exactly. So why should these 3 dimensions of space be the only ones?
Right.
We only are aware of them because they're big enough that we can be directly aware of them with these really faulty sensors that we have.
Right. If it's only your senses that limit that awareness,
Yeah.
why not, in principle, can we build something that can gain access to these higher dimensions?
Yeah, so there are experiments on the table. Some have been carried out, but more precise ones may be done where you study Newton's law of gravity. Why is Newton's law go like 1 over r squared? Why do we teach
That's
our kids
geometric.
GMM over r squared?
It's a geometric
sphere in 3 dimensions
Yes.
of space.
Yes.
Look at that sphere in 4 or 5 or 6 dimensions, and the 2 in Newton's law won't be a 2.
No,
It'll
it's
be
so-
a bigger number. The fall off will be differently.
Right.
And so look at the gravitational force on very small distances. Look for a deviation from the 1 over r squared that Isaac Newton told us about in the late 1600s.
Okay, because that's only in our dimensional measurement of it.
Yes.
Okay, because I'd asked you, again, over that same lunch.
Yeah.
Why did we have lunch? I forgot. We were just
We were
catching
hungry.
up. No. We were just catching up. It's my annual.
Go ahead.
No, Neil deGrasse Tyson just wanted to be the Jew's buddy and have lunch. That's all.
But do you see what he's saying? Right. So if you have our predisposition as we do for physics, if there were some type of humanoid species in that Liu Xiaozun book from the 3-body problem, how would they look at physics compared to someone like ourselves who's in a 2-body problem,
How
which
would
has
they,
a very, it's like you remember
how
how
would they look at our physics and our
it's like
physics?
chaos.
Our physics, because we're a 2-body problem, might have figured out a couple of things that the 3-body problem people.
Yeah. And you know how you got the chaos effect, right?
But obviously, they figured out something that we didn't.
Mhm.
So, which of the two of us, the 2-bodied or the 3-bodied?
Yeah.
it's
And
gonna
how do
work.
our,
If
how do you
we-
compare those maths? But that's being really convoluted. But to get on what I was saying, it was, it's essentially about like a chaos theory look at things. So I heard a scientist once, he was like, if you're on a moon on Saturn or a moon on Jupiter, there's no butterfly that flap their wings. So the chaos theory doesn't really posture itself as a logical definition as in relevance to as if you were on the Earth from the chaos theory argument, right? So this falls into that quantum parallel argument that they have, where so-and-so is happening here, but at the same time, in the sponge of space, so-and-so, there's also the exact same information happening X amount of light years away. So, falling back onto how we started this conversation, in that manifold perspective, how can you do math to travel that 3-dimensional quantitative mass globular thing in space that doesn't rely off of the equations of light, the equations of double the light?
Okay, all right. So a manifold could also sort of concentrate the oxygen that's going in to the system, right? The manifold sucks the oxygen, but it can also compress it a bit if it's well designed. The manifold could compress the oxygen going into the.
Yeah. And what's interesting is what's interesting if you think about this from a galaxy and universe perspective, we have that Latitakea thing where it's so vast and so large that the material that's getting sucked in at the top of my hand, there's nothing in between space time. There's nothing. There's literally nothing But in the bottom, which is light years away from the top of my hand to the bottom of my hand, there's nothing in between that we can go into and quantify or do math equations, but there's something coming out of the bottom of the asshole.
Yes. Yes.
But it's so far away. How does it get there? Where is the information being sucked into? Where is it being calculated?
just from
In
whatever stuff
in
gets
light year.
all of
But
the
don't forget.
stitch the fabric instead of folding a piece of paper and sticking a pencil through it. That black holes are weaving the fabric of space-time together. And
Well, what's interesting is all that material, let's just say for example, it's getting sucked in from the north. How long does it take before it's finally exerted from the south, like diarrhea?
I don't know. I don't even know what goes.
And remember, think about it.
I don't know what happens.
Think about it from the vastness of space perspective. When that material is finally exerted, even though it's existing quantitatively, where it's being taken in at the exact same time,
Where does it go?
it's being exerted out.
Yeah.
But supposedly it's like the same material. But what I think is happening,
it's this.
Listen to this.
Scattered. Maybe.
Well, what I think is happening at the bottom of these Latatikia things is that's where over time, which there is no time, but over time, these new expansions of that's kind of how you get new universes.
Oh yeah.
And it's not necessarily a big bang.
A big hooray! It's not a big bang, but it's a big hooray! Here we are. It's just a big coincidence. A big deal. Is it a big deal that, however, our universe decided to propagate? Here we are.
Yeah.
Is it a big bang? Is it a big hooray? Is it a good thing? Is it a bad thing? Is it just? It's just what happens in the universe, and the universe really doesn't really give a shit about you, Gay Dollar, or about me, 7 of 9.
Yeah, hold on 1 second. Looking for that video.
Fuck the universe. What do you think about that?
Fuck the universe. Oh, shit.
All it did was produce me.
Yeah, but in a quantum realm, you're produced infinity without time in one space in all spaces at the same time.
There is infinity of me. God bless eternity.
Yeah, God is really blessing you. That is absolutely correct. I'm looking for this video. Here we go. I think I found it. I may not have found it. I didn't. I'm still looking.
All right.
Still looking. I should have saved it in favorite places. I didn't realize I had watched so many videos on YouTube. Is it this video here? I don't think it is. Ugh. It's a new universe. Blacks and whites living together.
Have you watched Babylon 5?
Absolutely not.
No. So we are the universe trying to figure itself out. We are made of the stuff of stars. Somehow they coalesced into 7 of 9 and into Gay Dollar.
Yeah.
And here we are.
How is that possible?
I don't know, but it happened.
The randomness is beyond comprehension.
Yeah.
Where is this damn video? Fucking motherfuckers. All right, boom. Watch that. Yeah, yes. Dune 3, Cletus McFarland.
I like him.
Yeah.
Yeah.
Forbes News, Jason Casper. I'm gonna watch this video. Roger Penrose, good guy. Oh, here it is. I think this is it right here. All right, so this is what I find real interesting about everything that's going on with what they're finding, and it could be that expelling. You have to be really autistic to follow like how I
Trying to be as autistic.
understand how they are doing what they're doing.
Yeah.
Here. So it's really probing basically the earliest structures we know in the universe.
When you look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
We have been seeing this object already in the very early data we obtained nearly 2 years ago. And I think the
So what they're saying in this picture that they're just showing
This is old too.
is that is a whole nother universe.
Yes.
It's a whole nother,
That little line of dots.
yeah. And
is
it's
a whole
so
other universe.
it's so ungodly huge.
This is an old video. These fellows are using what sort of technology to?
Well, this is the James Webb stuff, and this is a newer video. And this is all pretty common knowledge with everything I'm talking about is pretty much what everyone else is talking about in this whole curriculum, I suppose.
Mm-hmm.
object already in the very early data we obtained nearly 2 years ago. And I think the surprising thing was that it's actually very bright. And so our initial reaction was that, well, it cannot be that distant because it's too bright. And so we took better data, and in particular, we also took spectroscopy. And we could clearly see that, no, that galaxy, that this yellow blob here, is really this most distant galaxy that we have ever seen.
Something very strange is happening in the early universe, and scientists have no clue why their theories are failing to explain these strange mysteries. Scientists are finding thousands of strange objects in deep field images, and they have no idea.
In each one of these that they're talking about,
Galaxy.
with how they equate their math, is like what we see, all those images in front of us, we're all a part of a sponge path, I guess is what you would say.
Yeah.
And that shit is so far.
Yeah, there's also images of the universal structure. Like they
Yeah.
sort of knitted all of the galaxies together and how they do.
Yeah.
And it does look exactly like a sponge.
And
You're
what
right.
they're saying, what they're saying is there's a vast shut the fuck up. And what they're saying is, in this image, there is a vast distance of nothingness. And that right there is like everything that we see in this image right here is everything that is in that tiny, like, so if they were looking at us and they were using the same example, it would have all of these universes before they even got to the emptiness of space to where they got to where that light came from. And that is an entire universe. And then there's vast distances of nothing in between it, but everything in between it.
I don't think it's another universe. I think it's another galaxy.
No. This is it's so big. It's so dense. It is what we are, separated by vast distances, that it can be calculated as like it's immeasurable and uncountable, the vastness of what space is, right? Even though Micah Smiller may not believe this.
I'd love it.
But this what they're picking up all these things here, sorry, I keep coughing. These are what we are.
Yeah. Stuff of stars.
In the distance, in the weight, in the light, in everything that it is.
So those are
Yeah. And
So
like that Lanakia thing or whatever the fuck that stupid Hawaiian name that they gave him.
right. Okay, so we have we're lucky enough to orbit a fairly stable yellow sun, like a full cycle sun or a star, in the habitable zone where liquid water can exist. There are some stars that are less energetic but last longer than our star. And it's possible for rocky planets to orbit their habitable zone with liquid water on it. I don't know. I find it difficult to believe that the only DNA in the universe is here on Earth. I find that difficult to believe.
Yeah, two-body problem. But you need to think so much more vast. It doesn't even make sense in math at like what this actual image is. Like this top left-hand thing here. This is so far away that in their equations of how old our universe is, this is older by X amount of billions of years. And it's so far away and there's nothing in between it. And then everything that we're looking at is like the little floaties in our eyes when we look at the sky, and they're extremely close to us. Like, so it's like the vastness is so.
But what does it mean to me?
Shut the fuck up.
Are finding thousands of strange objects in deep field images, and they have no idea what exactly they are looking at. Recently, astronomers have discovered many strange objects in the early universe, and they said that these are not galaxies because these objects are completely different compared to early galaxies. In addition, the Webb telescope looked deep into the universe beyond the Dark Ages for the first time, and what it found has astonished astronomers. Most scientists agree that the universe began about 13.8 billion years ago. However, the strange structures revealed in these images challenge this timeline and could lead to major shifts in cosmology. In light of these groundbreaking observations, several Nobel laureates suggest that the early universe might be vastly different from what we thought. Some even propose the radical idea that the universe may not have had a beginning at all. Instead, they speculate that the distant universe which we are considering as the early universe may actually be something else about which we have no idea.
Lambda CDM of cold dark matter and the dark energy that everybody considers a standard. According to that model, some of these objects they're seeing from the early universe are too massive. They'd have too many stars in them. It doesn't make
time to become that massive.
Well, all of the ordinary matter of the universe would have had to go into these things, and that just doesn't make sense. You don't have enough ordinary matter to produce that many stars.
So, what did the James Webb telescope...
Does that make sense?
Yes, I think.
...just see at the very edge of our universe? And why are scientists claiming these discoveries could change everything?
Hey, look, a gay man for you.
Since 1929, we have known that galaxies in the universe are moving away from each other. This is because the space between galaxies is expanding. Well, this expansion is not as simple as it seems. It has no center point, which means that wherever you stand in the universe, you will see that everything is moving away from you as if...
What?
It has no center point.
Yeah, but everything is expanding and contracting all at once.
It's heavy.
And if you remember, if you break that down in a quantitative level, and you take away space-time and what we know as physics today as a whole, everything that exists elsewhere, everywhere and all everywhere all at once and nowhere at all.
How many of you are there?
None.
One, at least one.
And so many.
If each point is the center of the universe. And scientists have also observed that space is not only expanding, but it is accelerating, which means that distant galaxies are moving away from us at a faster rate than nearby galaxies. Now let us assume that the Earth is located right here, and when you look deep into the space using the Webb telescope, you will see that everything is moving away from the Earth. As we know that the farther a galaxy is, the faster it is moving away from us. So when we look at distant galaxies, we will see that in a specific region in space, some galaxies are moving away from us at the speed of light. Scientists have called this region the Hubble sphere. And the galaxies beyond that region are moving away from us at a speed even faster than the speed of light. So common sense would say that we will never be able to see the light coming from those galaxies, because the light coming from these galaxies is moving away from us at a speed faster than the speed of light. But surprisingly, this is not true. We can still see the galaxies that exist beyond the Hubble sphere because the Hubble sphere is expanding due to the accelerating expansion of space. And as this region expands, it brings more and more distant galaxies into our view that are moving away from us faster than the speed of light. But there is a limit to how far we can see into.
Do what?
The Hubble telescope is kind of old, isn't it?
Yeah, but it doesn't matter if it's old. You can.
But it does matter if it's old. Voyager and Voyager 2 are very old.
No, all you need is
the solar system. So this one is just
one.
They had to give it glasses, didn't astronauts have to go up to the Hubble Space Telescope and fit glasses on it so it could take sharper pictures? I think they did. The Hubble sphere. It's probably a theoretical zone, an observed one. I don't know.
Anyway, I was dying.
Did you?
The satellites we sent out in space a long time ago, the ones that still exist, the information they send is like wavelength
radio
apparatuses. Just like the JB Webb telescope, we don't really get images. It doesn't really take a picture. It doesn't take a fucking picture. But it takes a picture of certain wavelengths through variations of whatever the James Webb telescope is, and through technology and through scientists, they're able to.
You see, do they make sense to you? Do you believe them?
Like when you actually look at the pictures of nebulas, it's not taking a picture of a nebula. It's
do you believe that Uranus rotates on a 90-degree axis?
Shut up.
It does.
To the universe, and scientists have called this region the observable universe, which is about 92 billion light years across. If you look at the edge of this region from Earth, you will see a universe that is filled with the cosmic microwave background radiation. This is because when we look deep into the universe, we are actually looking at the distant past of our universe. Let's think about this. The most distant galaxy ever discovered by the Webb telescope is Jade's GSZ 14, which exists inside this observable universe. And here we are actually looking into the past of the galaxy when the universe was just 290 million years old. Right now, this galaxy has gone beyond the boundaries of the observable universe, and we cannot say what it looks like anymore because the light coming from that galaxy will never reach us. Its stuff will have turned into some other stars or galaxies a long time ago. The universe exists beyond this observable universe. There are more galaxies and stars out there that extend to infinity. Remember that this boundary of the observable universe only for the species on Earth. For other species that live beyond this, the volume of the observable universe will be different. Now, according to our
What?
Venn spheres or Venn diagrams, Venn spheres.
standard cosmological model, which says that about 14 billion years ago,
And so what's interesting is this model is not real. It's not a real thing.
All right, so on the left is the Big Bang, and then
Yeah, and that
moves to the right, it expands and becomes our reality.
yeah, and that's not, as I understand it, and as the way people are explaining it today, is it's not a bang, it's the expelling from one quantitative state to another, and that expelling, like, and there's nothing in between that
Energy.
this matter travels through, which is fascinating. But it does travel through matter,
This
which
is
they
a
call a
aura.
black hole.
That image looks like an aura. Like, whoa. Like if I could have this image shooting out of my hands, like, pow, that'd be cool. That would be cool.
Well, it comes into one area and it expels out of another area, and it happens in multiple places all over the vastness of infinity, and it happens all the time. And with this telescope is the information that it's finding information that has so much density that it could be considered its own universe, because the density
Its own universe.
that we are receiving from it, if you take everything that we know in our known existence or our known observable universe, and you were to able to put it into a 3D map,
Yeah.
and you were to, if you were, if you were in that other region, and it would be exactly the same, right? Like,
Bro,
quantitatively.
We're working off very limited data.
Well, the data is improving.
Then there was a new one, and class is better. Looked at different things. They look at like infrared and look at planets and decipher the atmosphere by the colors that are coming back at the lenses, and they can separate out from the spectrum of. It's all such brilliant techno-mage kind of shit from Babylon 5.
Cosmological model, which says that about 14 billion years ago, the entire observable universe and everything beyond it that we can't see would have compressed into a tiny infinite point we call the singularity. Actually, no. I mean, that would be true if the universe is finite. But if the universe is infinite, and it kind of looks like it is, then it was always infinite. So the Big Bang would have happened literally everywhere. This means that the first galaxies did not form in any particular region of space. They formed everywhere in the universe, even beyond the observable universe that we cannot see. It seems as if matter came into existence everywhere in the universe at a particular time. And the cosmic microwave background radiation that we see everywhere in the universe is the first light of matter coming from every direction in the universe. So this is what our theories tell us about the size of the universe and how it came into existence. But wait, the new discovery of the James Webb Telescope is seriously challenging these theories, as we knew that when the Webb Telescope looks deep into the universe, it will see the first stars and galaxies at the edge of our universe.
What do you think?
But when the Webb Telescope recently looked into this region, It found many strange
What
bright
happened?
objects that do not seem to be.
Do what?
What happened? What cosmological event happened that brought us two together here tonight?
What caused? It's the event that always happens everywhere all the time.
Big Bang that
There's no Big Bang.
but we're one of multi universes, infinite universes.
Mass quantitative oozing secretion.
Are we special in any of this?
Absolutely not.
Huh.
We're secretions. That's
We
all
don't-
we are.
We don't matter that much, do we?
We're squirted out of this giant black invisible thing,
Hmm.
and it comes from another place that doesn't have space and time because it's so vast and so distant, and then you just show up.
We just show up. I think it's possible for the universe to have spawned the likes of us, let's say.
Absolutely. There are two-body problems everywhere, always existing in every time and never existing any of the time.
In every time, but never at any time.
Yeah, it makes sense, right?
Every time, but not any time.
Yep. Always existing and never existing, because that's what it is.
I'll have to think about that.
Yeah.
Early galaxies. Many observations have been made to.
These are all, like, technically, these are all
Have you seen
different.
that Mike Miller had shown with the molecules crawling across each other and how cells work? And is that like a little universe?
No, yeah, this is pure existence. These are everything that we are over there.
Yeah. And here we are.
In a different space and time. But we're able, but they're so far away and there's nothing in between them.
Right. How old is the universe? 14 billion?
Absolutely not. It's like trillions of years old.
Trillions.
Has to be trillions.
That makes the math work.
Yeah.
Yeah.
And when in these separate universes, these whole different things that are like us, but they're all the way over there. Do they have a YouTube? You know what I mean? Like, they are not. These places are not what we are. They are them.
Alpha Proxima should have its own Twitter.
No, these are so much far. These are so fucking far away.
Okay, so Alpha
Centauri,
right, is 4.5 light years away.
Yeah.
So light only takes 4.5 years to get there.
No,
that's like the closest. What is it? The galaxy?
It's 4.7 astronomical units.
No. Astronomical unit
is 4.7 billion astronomical units.
Understand?
You're thinking too small. You need to think bigger and picture what I'm saying. These things are so much bigger than galaxies. That they are. These are universes.
I know.
You don't know.
Yes, I do.
More about these objects, but scientists have failed to understand them. Recently, scientists conducted a study published in the Astrophysical Journal. Researchers found 87 galaxies that might have existed just 200 million to 400 million years after the Big Bang. This discovery shocked scientists because our current theories suggest that the universe shouldn't have been able to form so many galaxies so quickly. Hao Jing-yan, an astronomer and one of the study's authors, stated that even if only a few of these galaxies are confirmed to be real, it would mean we need to rethink our understanding of how galaxies formed in the early universe. Take a look at this fascinating image. It shows a unique early galaxy that challenges everything we know about galaxy formation. Normally, galaxies are made up of a variety of materials, such as gas and dust that orbit their center. These materials are crucial for the formation of
I hate these images because they're fake. They're artist renditions. It's not actual images. I kind of like what he's saying, but I don't like the images or the music.
stars. After observing many galaxies, scientists found that at most only 10% of a galaxy's gas turns into stars. However, the Webb telescope recently identified 3 galaxies from the early universe that have puzzled astronomers. Spectroscopy data from these galaxies reveal something extraordinary. They have turned 100% of the material around them into stars. This discovery is surprising because, according to our current cosmological model,
100%, all of it.
So it's like what you would call the Big Bang. These are Big Bangs happening. These are the anal orifices of the quantitative, like there's something on there's something somewhere else, X amount of light years away, that is absorbing all this energy, and it's coming out of here.
Wow.
You know what I'm saying? And it's fascinating shit that they're finding.
It's been edging.
it is thought to be impossible for a galaxy to turn all of its available. These materials are crucial for the formation of stars. After observing many galaxies, scientists found that at most only 10% of a galaxy's gas turns into stars. However, the Webb telescope recently identified 3 galaxies from the early universe that have puzzled astronomers. Spectroscopy data from these galaxies reveal something extraordinary. They have turned 100% of the material around them into stars. This discovery is surprising because, according to our current cosmological models, it is thought to be impossible for a galaxy to turn all of its available atoms into stars. These unexpected findings are causing a lot of confusion among astronomers.
Right.
They are questioning how these galaxies.
Do what?
That doesn't ring true. That this star somehow managed to turn all of it.
Because it's the Big Bang. That's where what we are today is happening there at that time. That's the creation, that Big Bang theory is what that is. This mass accumulation of data in a quantitative state.
In a quantitative state,
Am I
how
still
much
here?
quantity of data have humans gathered beyond Voyager 1 and 2? Voyager 1 and 2 are the only 2 things that humans have created that have escaped the solar system. And they have far less computing power than, I don't know, Ford Pinto or a Chevy Citation or something. And what does it matter? Does any of this matter? It's all interesting.
It is interesting.
But does it matter?
What is that damn thing called?
Light squared.
3D diagram of space vacuum space.
The universe.
Latitude. Is that what it is? I'm trying to. for a specific video.
There's all like clusters of galaxies, right? That sort of form, and that if they're met, they all form strands and nodes. Some nodes are kind of spread out. That's cool. Wait, that I think the way that I think that the sum of human knowledge has taught me.
Yeah.
Yeah. Ish. Kind of. Isn't this device right here, $K, that we have the sum of human knowledge in the palm of our hand?
Well, that we're allowed to know.
Well, how much can we know? How much can I know? How much can you know?
A lot.
Right, but not everything. But you have access to everything.
No.
Are you sure?
I can't find that video. I knew I should have saved it. But it's a pretty good. Oh, I can't stand this. Is getting on my nerves, like the dancing.
I like the Mickey. I like Mickey.
Stamps. Some stamp.
Oh, stamp collecting. Oh, phlebotomy.
Lobotomy. Oh my god. Oh.
Phlebotomy. I think that might be blood. Something. I don't know.
Oh, DARPA, why won't you give me what I'm looking for? Working. No. It's not it. Oh, I wish I could remember the diagram's name.
What city is this? It looks Asian.
Vacuum diagram. It's not what it's called, but oh man, it would be cool if I could find that video. It's a really good video to really emphasize what I was talking about earlier.
So they did image the and it does.
What are you saying?
That they image universe. What we can look at, and it does look like it's like it looks like
You're breaking up really bad. Possibly.
Yeah, better. The universe has been imaged, and it does look like I kind of think I understand what you're saying, but sometimes not.
This may give an idea. This image right here, the yeah, like so the weight of the material gets so heavy that quantitatively the material drops itself, I don't want to say like in another realm, but wherever it goes, X amount of like a ludicrous amount of light years away, the material is spit out. And that is technically how you
That's an
have your Big
upside down.
Bang theory.
Have you seen those videos where they drop a water drop and then it goes up? It's one of those upside down.
Yeah, so I'm not talking about the false vacuum theory, but
That's
the
water
way
upside down,
this is a very good diagram
like an eyeball.
of
Yep.
getting across like how the data somehow the data in this range here visually
Yes.
gets completely obliterated and quantified at the same time, and the
yet-
information through like gamma ray expulsion, even though that may not be what it is, but just to give a visual idea, is what ends up coming out on the other side. But the distance and the vastness of these two areas is it's so fucking huge.
The distance between that gap is huge.
I mean, it is just so fucking huge.
Mind blowing.
Mind blowing. And then you get your quote unquote Big Bang, but it's really not a Big Bang.
Yeah.
Yeah. So this is a good visual representation, but I think they have done better at the math.
Or drop your quarter in one of those big yellow things, shaped like a big funnel, and it rolled down.
Yeah. And then somehow magically in a whole nother place and time, outside of space and time, outside of reality and math and physics, it shows up.
What does it matter? Here we are talking to each other, Hey, how are you? I'm fine, thanks. Talking to each other. What does it matter how the universe came to be? What does it matter that you and I are speaking to each other right now? Other than I guess.
All of a sudden you got quiet. Oh, okay. Are you there?
Yeah.
Yeah, I'm going to get some water.
All right. I'm going to pee. What did we talk about? The vacuum manifolds. We talked about that. We talked about the three-body problem. We talked about that. So, dark matter, dark energy. Breakfast of the quant. We talked about the breakfast of
What
the
do you
quant.
get when
I'm
Zaxby's,
not sure.
an iconic
I
chicken
know
joint,
exactly what that
applies?
means. And we're talking about algebra
Do what?
equations. Wow. You're back. Took notes. I took notes.
Nice.
So, what does it matter? Times the speed of light squared that you and I are here speaking to each other right now. Matter. It's all very fascinating. I can't do the math. Maybe some of the theory. I don't know.
Here's something pretty cool.
Hi guys, it's Quinn here. If you appreciate my content, consider hitting the like button. It's the only way the YouTube algorithm notices me. In this video, we break down the full timeline of the 3-body problem series in 9 minutes. Some events will be left out for time's sake, and also keep in mind that this is just a timeline to provide perspective. For a more detailed breakdown of these events, check out the 3-body problem playlist linked in the description. This video will cover the main 3 books in the series, not including the spin-off Redemption of Time. The 3-body problem series, aka the Remembrance of Earth's Past trilogy, tells the story of humanity over the course of our existence in the cosmos. The series starts in the modern era and spans out to the end of time. Many significant events also take place before the opening of the story. The Common Era. We begin in the Common Era, which is any time up to the year 2010 AD. All dates in the Common Era are marked with the epoch CE. During the Common Era, humankind remained ignorant on the true nature of the cosmos and on the true nature of what waited even within as short a distance as 4 light years from our solar system. In the year 1968 CE,
nature of cosmos. Can we possibly know the true nature of the cosmos?
Yeah.
Are you sure?
Yeah, sure.
We can? We're that smart?
If your math is good enough.
The Red Coast military base was established at Radar Peak, located in Inner Mongolia, Greater Kingon Mountains. The defining characteristic of the base was the huge dish pointing upwards. In 1969 CE, Yawinji is sent to the Red Coast base. During 1971 CE, Yawinji receives a signal at the Red Coast base, a response to the one they had sent out into outer space. It was the first ever message from an extraterrestrial life form received on Earth. Yawinji responded to this life form, even though it warned her that its species was hostile and would invade. Yawinji is ultimately responsible for the devastating events to come later in the series. In 2010 CE, it became widely known that the alien life forms known as the Trisolarans are on their way to Earth and will arrive within the next 400 years. This marks the end of the Common Era and the beginning of the Crisis Era. The Crisis Era. In the year 2013 AD, or year 3 of the Crisis Era, the Wallfacer Project was enacted as a way to combat the Trisolarans' ability to view all activity on Earth in real time, thus exposing all human plans to thwart them. In the Crisis Era year 7, Shang Xin enters hibernation. In year 8 of the Crisis Era,
years. They said over the next 400 years.
Yeah.
It would continue to
Yes.
Humans can accomplish a lot in 400 years. That is the tactical error.
Yeah.
Wallfacer Luo Ji sends out his spell, a signal targeted at a distant star system. The same year, Luo Ji is cryonically frozen and enters hibernation. In the year 154 CE, the star system 187J3X1 is destroyed as the result of Luo Ji's spell. In the year 205 CE, the Doomsday Battle against the Trisolaran Droplet leads to the destruction of humanity's entire space force, apart from 5 vessels who eventually named themselves Starship Earth. The same year, the Battle of Darkness occurs among Starship Earth. All but the vessel Blue Space are destroyed. In the year 205 CE, Luo Ji outwits the Trisolarans, leading to the Deterrence Era. The Deterrence Era. In the Deterrence Era year 61, Shang Xin awakens from hibernation. Around the year 61 of the Deterrence Era, the vessel Blue Space encounters fragments of the 4th dimension. In the year 62 of the Deterrence Era, the first ever sword holder election is held, and Shang Xin was chosen. In the year 62 of the Deterrence Era, the Trisolarans strike after the transfer of the detonator switch, ending deterrence and ushering in the post-deterrence era. In the year 62 of the Deterrence Era, the droplets alongside the vessel Gravity attack the vessel and are eventually disabled by the inhabitants of Blue Space through use of their understanding of the 4th dimension. The Post-Deterrence Era. In the first 5 days of the Post-Deterrence Era, some of the inhabitants of Blue Space and Gravity enter the 4th dimension and encounter the Tomb. In year 1 of the Post-Deterrence Era, all of humanity on Earth is confined to Australia, effectively what was intended to be a genocide. In the year 3 of the Post-Deterrence Era, the inhabitants of the vessels Blue Space and Gravity trigger the gravitational wave broadcast. This reveals the location of both Earth and the Trisolaran homeworld to the rest of the universe, dooming both worlds, but
we've been doing that. We've been sending radio waves out for how many hundreds of years now? 1.5.
Giving away our location.
Yes, exactly. Making waves on the water. Yeah.
What's really cool, like one of the underlying stories inside of, like, in this story, there's multiple stories, very convoluted, but essentially inside of all of existence, creatures have 2 ways of living. They either go into obscurity or they destroy everything that they encounter.
Oh, why can't they have fame and fortune? Why can't they be happy?
Yeah,
well, not fame and fortune and not happy. Those 2 are
one or the other.
All right.
Hide or destroy.
Why can't they just be happy and boring?
but freeing humanity from Trisolaran tyranny. This begins the Broadcast Era. In year 3 of the Broadcast Era, Trisolaris is destroyed, with only the members of the Trisolaran fleet surviving. In year 8 of the Broadcast Era, a scientist named Wei becomes fixated with the nature of black holes. His experiments would eventually lead to breakthroughs in the science surrounding FTL travel and the creation of black domains, which could hide regions in space.
We are not a traditional cafe. We're completely unconventional, and my Wix website really has to capture the same magic.
From dark forest attacks.
Huh?
I like the pink Lamborghini.
The Bunker Era. In year 1 of the Bunker Era, the Black Hole Project begins. In Bunker Era year 11, Shungzin awakens again from hibernation. In year 12 of the Bunker Era, the Black Hole Project ends after the death of Wei. In Bunker Era year 66, the dual vector foil is detected sweeping past the Oort cloud in the direction of our solar system. At the time, humanity cannot identify the object. In Bunker Era year 67, Shungzin again awakens from hibernation. In Bunker Era year 67, the dual vector foil arrives in our solar system and begins the process of collapsing the solar system into 2 dimensions. Here is where a discrepancy appears in the text. It states that humanity detected the dual vector foil in Bunker year 66, and yet Singer, a member of a race of highly advanced beings depicted in Death's End, in fact launched his dual vector foil towards humanity in Bunker Era year 67. This could be a mistake, though it is highly possible that this indicates that the light from our solar system simply took time to reach Singer. By the time he launched on us, another advanced race had already noticed humanity and began the destruction of the solar system the previous year. This would be in line with how the Dark Forest hypothesis is portrayed in the series.
Trying to destroy our solar system. Why would their first response be to destroy our solar system?
Because either you hide or you are the destroyers. That's the only 2 options.
You're a monkey in a zoo.
Yeah.
Yeah.
In Bunker year 68, the solar system succumbs to dimension collapse. In Bunker Era year 68, Shungzin and AA escape the solar system in humanity's first ever faster-than-light ship. The Galaxy Era. The first 400 years or so of the Galaxy Era take place while Shungzin and AA are traveling in an FTL ship, thus time dilated for them. In that time, humanity had expanded greatly and inhabited several worlds, comprising several human civilizations. In Galaxy Era year 409, Shungzin arrives at Planet Blue in the star system DX3906. In the Galaxy Era year 409, Shungzin is trapped by death lines. In the Galaxy Era year 18,904,138, Shungzin enters the Pocket Universe 64, a universe outside of the normal universe's time stream. The Three-Body Problem series spans from the Common Era to the distant future. We start off with an alien message in 1971. This marks the beginning of humanity's struggle against the hostile Trisolarans, and the beginning of humanity coming to understand the hostile nature of the universe itself. Thanks for watching, guys. Make sure you like and subscribe.
Does the universe give a shit about you, Gay Dollar?
I hope so.
Huh?
I hope so.
Yeah, I do. So that's a small bit of the universe giving a shit about you.
But even though that was a 9-minute
I am
synopsis
made
of that,
of the same stuff of stars that you're made of.
what?
I'm made of the same stuff of stars that you're made of. I'm trying to figure out the universe just like you are. And somehow the universe universes have brought us together here, communal, sharing our thoughts, just chatting.
Solar system lives another species. They have heard the call of Earth from the vacuum of space. And
so what's cool about this story is so it takes place with that lady from the Chinese doing the Tiananmen Square and all that stuff, 70s and 80s. And she's talking with that alien who ends up killing everyone and flattening it into a 2-plane existence, which is the Singer. And the Singers are their own race. And then in that story, you have, because the Trisolarans are like insects, you don't really, in the book, you never figure out what the Trisolarans are or what they even look like. It's like a hidden mess. It's meant to be determined by like what your brain can create by what you're reading. And one of the Chinese dudes who were with that lady who ends up becoming like the sword maker or whatever she's called throughout history of all time, and she ends up living throughout all of time to the end of time. Her
Does she have
her
babies?
love, well, her love of her life, like they take his brain because he's like dying of cancer or whatever, and they take his brain and they put it into space, and the Trisolarians ends up finding his brain in space. And then there's another story in that same book, which is about the guy who's studying black holes. So there's a cool little convoluted story thrown in there. And the man ends up committing suicide by taking himself off of the space station and drifting into the black hole.
Did he save people?
Yeah, and there's a cool story about that. And then there's another story which is about the blue spaceship. And what's interesting about that story is they end up going like 13, 14, 15 million years into the future. And when it takes them light years upon light years to slow down, because even though they created the technology to go as fast as speed of light, they never created the technology to technically slow down. And so it takes them millions of years to slow down, and by the time that they end up slowing down, because of dilation of time,
I think Brian Cox said that once, that if we go from here to Alpha Proxima, which is 4.5 light years away, it would take us the blink of an eye, and then when we come back, take the blink of an eye, but 4.5 million years would have passed on the Earth.
Yeah, and there's another part of the story where that lady who ends up surviving it all, she ends up meeting somehow through time dilation one of the ancient
it's Bill and Ted's Excellent Adventure kind of shit.
Yeah, they end up somehow, one of the spaceships of time end up on Pluto because X amount of millions upon millions of years ago, the only way that the human species were able to get writing into the future was to carve it into stones. So they end up finding stones on Pluto that gave all of these mathematics. Bro, the story is so fucking dope. It's a fucking crazy story. And that's just like one of the 7 stories in the book. And in this time, in this era, they have portal doors. So these doors open out of nothing, and they have no frames, but they exist in space and time. And there's also another story inside of these stories where
Gnarls Barkley has a video kind of like that. I'm going on. I think it's the name of it. Where this little feller finds a portal to another dimension.
Yeah.
And he runs through it. Yeah.
And there's another story where because as humans expand through space and time, there's different epochs of things happening.
Mm-hmm.
And one of the epochs of the humans who decided to hide on one of the spaceships, they end up surrounding their entire universe, and they collapse themselves into a black hole, never to be seen again. And they are outside of time and space itself. And there's like a little story in that as well.
But they knew what they were jumping into, though, didn't they?
It's really cool, dude.
turn back the clock, making moves that I thought I wanted back at 21, 22, 23, 24, never wrong. Thought I was never wrong and better off, just wanted less. But I knew all of me wanted more.
It's like that.
I never knew my chances on the way up. See, let the kids stay. Knowing you with the grown-ups now. I never knew my chances on the way up. See, let the kids stay. We was at the kids stay. I'll trust no rust with the pen, no. We do not play pretend, no. Hide and seek, that depends. No ifs, just when now. Throwing cash in for the win now. Yeah, we gon' win. Always true outside the line.
I mowed the front yard today. My legs are tired.
Attaboy. Good job. Got it done.
Now I need to do the backyard.
Tomorrow.
It'll take me like a week.
What? A week to do the backyard? 20 acres.
What is this game?
You matter to me times the speed of light squared. Okay, dog.
Not a lot of bit or a little bit?
Times speed of light squared. That's pretty powerful.
Yeah, but that can be a lot or a little bit.
All right, then a little bit.
All right.
No.
You got anything else to talk about?
No.
I feel like we talked about a lot tonight. Talked a lot about space.
Yep.
The manifolds of space and how they disregard time and light completely.
Yep.
And somehow they exert energy countless light years away, so much, so far, so distant.
Yeah. We talked about reality itself, bro.
In the fuzziness in between, and then one day it just shits out new stuff.
I think we can figure it out.
Yeah. I got it all figured out.
Yeah.
All right, let's go to bed.
All right. Bye.
Bye. You leave. Okay. I feel like going to bed. Should I go to bed? I see Fascist Kirk has been talking in the chat. I haven't blocked. If you would like to join, you can join. Can't see your words.
Scientists.